Hello, this is Mr. Hendry does balancing equations, and I'm just going to go through how we balance chemical equations, and I'm going to use the combustion of alkanes as our two examples. So in our first example here, we've got the complete combustion of ethane in our reaction, so it's reacting with oxygen to produce carbon dioxide and water. Now, the big question that would be in an exam would be, can you balance this equation? So the first thing I'm going to do is draw a line at our arrow here so we can separate into the reactants and the products of our reaction. So what I want to do is count up the number of atoms of each element in the reactants first. So we've got a small 2 next to the carbon, so we have 2 carbons, a small 6 next to the hydrogen, which means we have 6 hydrogen, and a small 2 next to the oxygen, which means we have 2 oxygen. We're going to do exactly the same for the product of the reaction. So when there's no number, that means there's 1 carbon. We have 2 oxygens here and 1 oxygen here, so they need to be added together. And we've got 2 hydrogens. Now I always make sure that I've got the same element at the same step in my column of elements. So it's easy to check which one's which and whether we are balanced. Now, as we can see, there's not the same number of atoms of each element on each side of this equation, so this is not balanced at the moment. So we're just going to work from the top. So we've got 2 carbons on this side and 1 carbon on this side. And what we're going to do is we're going to add a large 2 in front of this carbon dioxide. That'll signify that there are 2 molecules of carbon dioxide in this reaction. So we can then show that there's 2 carbons, so they are now balanced. We've not done anything to the hydrogen, so at this stage we still have 2 hydrogen. And for oxygen, we now have 2 multiplied by 2, so that 2 still applies here. So we've got 2 times 2, 4 oxygens here, and 1 oxygen here. So we have 5 oxygens in total. So this equation is balanced for carbons, but not for hydrogen and oxygen. So we've got 6 hydrogen on this side, 2 hydrogen on this side. So we're going to add some more hydrogen on this side to balance the equation. So we're going to put a 3 in front of the water to give us 6 hydrogens in total here. So we're going to have 3 multiplied by 2, 6 hydrogens in total. Obviously this changes the number of oxygens as well. So initially we had 2 times 2, which was 4 oxygen. We now have 3 times 1 as well. So 4 plus 3, we now have 7 oxygen. So our carbon is balanced, our hydrogen is balanced, and we now need to look at oxygen. So we now have more oxygen in the product side than in the reactant side. So we're going to go back over here and add in more oxygen to balance this. So at the moment we have 1 molecule of oxygen on this side to give us 2 atoms in total. Whatever number we're going to put here to balance the equation, we'll multiply by 2 and we'll have to match what number we have over here. So to get from 2 to 7, we're going to multiply by 3.5, and we're just going to put 3.5 molecules of oxygen in this equation. We'll double check to make sure everything balances, so 3.5 times 2 to give us 7 oxygens, and our equation is now completely balanced. I'm going to do another example, and this time looking at the incomplete combustion of ethene. So we've got ethene plus oxygen going to carbon monoxide plus water. So we're just going to do exactly the same as what we did last time, and we have 2 carbon, we have 4 hydrogen this time, and 2 oxygen to start with. We have 1 carbon, we have 2 hydrogen, and we just have 2 oxygen to start with here. So again, we're going to start at the top, and we're going to put a 2 in front of our carbon monoxide to balance the number of carbons. So remember, we can now do 2 times 1 to give us 2 carbons, so these balance. We've done nothing to our hydrogens, and we now have 2 times 1, 2, plus 1, we now have 3 oxygen. Again, the same as last time, we're going to look at, we've got 2 hydrogen here, we need to get to 4, so we're going to put a 2 in front of the water to give us 2 multiplied by 2 to give us 4 in total hydrogen, which is the same as what we've got in the reactants. Once again, we need to make sure we count the number of oxygens each time. So this time we've got 2 times 1 to give us 2, plus 2 times 1, we have 4 oxygens in total. After doing that, the carbon and hydrogen are balanced, but we have 4 oxygens in the products and 2 in the reactants. So we need to now balance the left-hand side of the equation. If we've got 2 atoms of oxygen here, we're going to need to multiply that by 2 to get 4 in total. So 2 times 2 is 4. We now have 4 oxygens in our reactants, 4 in our products, and this equation is now balanced. So what I want you to do is to try this equation at the bottom here, and this is the complete combustion of butane. If you pause the video and then come back and have a look at the result once you've tried it. So now that you've tried that one, you should have got that butane plus 6.5 oxygen go to 4 carbon dioxide and 5 water. I hope this video has helped you in working out how to balance equations, especially in the combustion of alkanes.